Good morning, good afternoon, good evening. Welcome again to day 3. Very excited to see you all here. Today we kick off the technical sessions for our convening this week, our online community meeting this week, with 2 days of technical updates. Today focuses on updates from work streams, and tomorrow focuses more on proof of concepts. So we will kick off today with the OSS Core report out. Sam and crew, take it away.
Thank you, Simeon. Good morning, a very good early good morning, in fact, to our friends from the West Coast. Good afternoon and evening to our friends from Australia and the Eastern time zones. Simeon, can you please confirm if you can see my screen in presentation mode and my audio is okay?
Yep, I can see you and I can see your presentation. I can hear you clearly. Go for it.
Thank you very much. So I have with me Miguel and Valentin today for some of the feature updates. Along with that, we'll have Simeon and, we have Godfrey and James briefly coming in as well for a cameo. So today, we are on the 3rd day of the convening. Thanks everyone for joining again. I'm thrilled and honored to be here. I'm not that expressive, but that's true. My name is Sam Kumari. I'm working with the core team and a part of various councils, and also supporting some work streams, which we'll go into today and tomorrow. So the past 2 days, we looked at the business side of Moduloop, where we are, how the perspective for the future looks like. Today, we'll focus on where Moduloop is from a use case perspective, with a technical perspective primarily, so that it will help us plan for the future and the roadmap discussions on day 5 to build on this. We've categorized this into 5 major groups. We'll do an intro and overview of Moduloop, and then we'll look at some of the feature updates on continuous cross settlement and notifications, look at the Helm release update, some maintenance updates, and we have a separate session for the testing toolkit tomorrow. So first, starting with the report out agenda, we look at the overview of Moduloop, the changes and progress. After that, we look some of the community updates and contributions, PI 12 focus areas, and then wrap up with a look towards the future. So for PI 12, for those of you who are especially new or have lost track of the phases and the program increment numbers, so the grayed out areas, we have passed 4 phases of Moduloop so far: level 1 project, road to production, supporting adoption and deployment, going live, which was our previous phase 4. So the PI 12 here, our focus was on hardening, packaging, releases, and prep for phase 5. So that just ended. And as we kicked off this community event, we are right now kicking off the program increment 13, also kicking off the phase 5 in the evolution of Moduloop. So I've taken the one loop for all Moduloop in motion statement that the Moduloop Foundation came up with. And the themes also here are reflected what Paula mentioned on day 1: removing friction, understanding, addressing gaps, cost reduction, increasing trust and confidence in Moduloop. So technically looking, the 4 focus use cases for Moduloop on the open source side especially have been started out with P2P. Then we built on it to have the merchant request pay use case, and then extended to support bulk payments. The PISP use case, the third-party initiation use case that has garnered so much interest, stirred up interest these days, has an initial deployment. Our goal is to work towards an MVP. There is a PISP session later today in which we'll go into details. So we're still in the partially implemented initial implementation phase there. Apart from that, everything else you're looking at the details on the payer initiated transaction, the payee initiated transaction, and the bulk payments are all supported. So we did some enhancements to these in the last program increment, and we look at what are the areas that we touched on there. Here again is the FSP interoperability version 1.1 implementation status. So we have all the use cases covered so far. There are some grayed out areas here, not because Moduloop does not support it. Moduloop actually supports it, but there are things like point of sale devices, ATMs, agents, and other aspects that are involved, which are primarily FSP related aspects. So the core rails support all these. So as you can see, the blue dots here have been tested. Some of our friends from Applied Payments and COIL have tested the ATM and POS that are payer initiated. There are some others that are supported, but need some testing, the agent initiated stuff that I talked about. It is important to note that the bulk payments use case that is supported is based on the version 1.1 definition in the FSP interoperability API. So we're working on enhancements for that, but that's for the future. So here is a more granular status. So we've touched on transfers, the parties and participants, which are part of account lookup, authorizations, and the bulk uses for enhancements in PI 12. What they are, we'll look at in the coming slides. On the operations side of things, the settlements feature is one of our focus areas that for this PI, for this past PI 12. So we now have the capability for query and create ledger account types, configure and query settlement models. So as part of the continuous cross settlement work stream, the finalizing of that involves standardizing, making sure it's OSS ready, and merging it into the master branches so that it's available as part of modular release for use by our adopters. So we have the interchange fees and continuous cross settlement now available. Earlier they were implemented, but were not part of master branches. So we'll look into that in a bit of detail today. Then we have the PI 12 component architecture. I would like to invite Miguel to take us through this architecture.
Hey everyone, I'm Miguel de Barris. I've been working on the modular project for the last 2 years as an architect. Let me take you through the component architecture. I'm not going to do it in too much detail. If you want more detail, please go to the Mojo 103 course. I go in a lot more detail and even more detail that you can imagine. So please go ahead for that if you want more detail. Okay, so this is just an overview of all the components that we have. It's not extensive by any means, but it's majority of the main components that we have within the modular platform. I'll take you through the most primary ones or the most important ones. Sam, if you could go next, please. So we have the core components box in the center of the diagram, and there we have microservices. Generally, all these boxes are almost representative of a microservice per se, but we have the account lookup service, which obviously handles the routing of party lookup calls between participants, as well as resolving the link between a party and a participant. It's done, is done through that service as well. We also have the quote service, which is obviously the service that we use to resolve the agreements prior to executing a transfer within the modular platform itself. And the next, we have transfers. Sam, if you go next, please. Which you'll see is broken up into more than one microservice. And that's done for several reasons, but the main important ones are, let's say, the ML API adapter, which is on the top left there, you can kind of see in the green box, which is the adapter that we have for receiving FSP IOP requests. We also have a notification handler to be able to send those notifications out to participants. And you'll see a bit later on discussing a design about how we can make that more reliable. And in the other components there, which are marked as central services, are really the components that are processing the individual steps of a transfer. So, for example, we have the prepare handler, and we have the fulfill handler, and we also have a position handler to be able to manage the position changes, etc. And we also have services for requesting and querying transfers, and an admin API to be able to make changes to the central hub itself. Next, we have, next please, Sam. Next, we have on the far, thanks. And just related to that, transfers, we have bulk transfers on the far right, which are also divided up to several components, depending on whether it's preparing or fulfilling, etc. We also have the transaction handler near the bottom, and that basically handles the agent and merchant payments, as well as authorizations. We also have the third-party API, which you'll hear more about later today, which is basically just about the payment-initiated service provider payments. And we have a bunch of other supporting components down below, and you can see that we have central settlements there. And we've now enhanced that by adding a new component, which is referred to as the transfer handler, which now provides the CGS and the continuous gross settlement, as well as the interchange fee calculations and processing. That's now been newly introduced into the settled settlements components, which you'll hear about more later. There's a bunch of other components below that for handling email alert notifications, as well as components for processing internal logs, audits as part of the event stream processor. We also have Event Sidecar, which actually collects those logs and audits, etc., from each of the components that are running above. We also have a Oracle component, an ALS Oracle component, which is a pluggable adapter within the account lookup service, which allows us to plug into different registries where people can then do the resolution between a participant and a party. And we also have the scheme adapter, which is a pluggable, which is an SDK to be able to build connectors to Moduloop, predominantly from a participant's perspective. And the last part we have there is the finance portal UI, which is just basically an interface to be able to see what's going on within the switch to some degree. You can see bulk transfers, etc., as well as some participant information. On the left of that, we have a persistence box. So that's just showing us all our persistence backends that we have. We have Redis for our caching. We have MongoDB for our object store. We have MySQL, which is used for our consistent data store for transfers and settlements. And we also have Kafka, which is used for connecting the central service components in a durable, persistent manner, messaging consumer-producer pattern that we use, which we use for event-based processing of the transfers itself. And the colors you see there are, I mean, it's not because we're into psychedelic drugs or anything like that, but they're actually there to show the relationship between the persistent stores and the components. So you'll notice, for example, if you look at the email handler just below the central settlements components, it starts off at a darker blue and it goes to a lighter blue. So that's just showing the dependency of that component has to those persistent stores. Above the persistent layers, we have our quality assurance components. And that's basically where we have our tests. We have quite a few functional tests written in Postman. We also have scripts for onboarding of hubs, participants, and as well as setting up simulators themselves. And speaking of simulators, we even have simulator components, which are actually built on top of the scheme adapter component that was mentioned earlier, available. And you can use a simulator either as a hub or as a participant. It's flexible enough to be able to operate in those ways. And below that, we have the testing toolkit. And this is a nice user interface friendly version. And you'll see a demo a bit later about that in terms of how we actually use that to test and verify operations within the Moduloop platform itself. And below that, we have a capability to validate our licenses, do some auditing on our components and make sure there's no security issues on the underlying dependencies that we rely on within the platform code base. On the far left, we have the software development kits. So we have a Moduloop SDK, and that's actually what the scheme adapter is actually built on top of. And below that, we have an Oracle SDK, and that's basically just an accelerator for creating an ALS Oracle. So basically a registry, once again, to do a lookup between a participant and a party, which is potentially stored within the Moduloop platform, or it can be hosted outside by a third party if necessary. But that can be used as either an adapter, or it can be used to create the registry itself. Below that, we have an event SDK, and that's a component that links the event stream process and the event sidecars together. And that's actually the component that produces the logs, the errors, the audits throughout our system. Below that, we have the operational monitoring. And this is basically where we collect all the logs in a centralized fashion. and where we index them, where we're able to search through them and provide that operational monitoring capability. And as part of that, we also support tracing, open tracing, specifically when we receive a transfer or some kind of request within the system. And as you saw for the transfers, we have several microservices that a transfer would be processed through the life cycle as it's flowing through the system. As such, we use open tracing to be able to interlink those and connect those per each transaction, and we're able to see how it flows through our system, as well as determine if there are errors, or be able to basically view the logs associated to each of those steps of the processing itself. We also have an ability to view near real-time metrics through a Grafana dashboard, which we predominantly use for performance testing, but it can also be used for alerting, etc., based on reporting of the health of components, etc. Below that, more or less in the middle, we have our container management and orchestration layer. So inevitably, we want to make sure that Mojo Loop can run anywhere, whether it's on-prem or whether it's in the cloud. As such, we have technologies, for example, like Docker, which allows us to containerize all the microservices that we talked about a bit earlier. And on top of that, we need a way to manage and orchestrate them. As such, we rely on Kubernetes to be able to do that, and as well as provide the ability for us to exact policies on that infrastructure and our services from a security, a scaling perspective, and as well as a high availability. And then the last point on there is Helm. So we use Helm as a consistent means for us to deploy, install, update, roll back Mojo Loop installations via a configuration-based package manager. On the bottom right, we have our continuous integration and delivery components. So this more impacts the open source side of things, I would say. Majority of them, for example, we have Circle CI, which we use for our testing, building, and deploying of our components within the open source labs and environments. We have Docker Hub, where we store our Docker containers. We have the NPM org, where we store our development libraries. And we have Gitbooks, which is used for rendering our technical documentation. Something new there, which has always been, let's say, marked as a future contribution, which I'm very, very excited about, is now that the infrastructure as code piece is now being introduced and is now being actually contributed to the open source. And you'll see a demo a bit more later about that as part of the payment manager, I believe. And that's great, because this is literally an automated way. Think of it as a button that you can press and you can install Mojo Loop and install it in a way that's more consistent with a real life deployment in terms of adding security onto Mojo Loop itself. And you can actually see at the top, we now have an API gateway, which provides security bolted onto our APIs. And it includes things like OAuth, as well as helping us ensure that everything is secure and encrypted via MTLS. Thanks.
Thank you, Miguel. Sorry about that. So a few community updates. Thank you, Miguel, for covering that. We have the infrastructure as code contribution, which we'll see later today. Apart from that, we have the continuous cross settlement and interchange fees that were contributed earlier, now being absorbed and assimilated, and will be available with our new Mojo Loop release, Helm release. Apart from that, we have various work streams that we are involved in, the reliable notifications and the cascaded timeouts work streams. We have the QA and the architecture, the performance POC and follow-up, code quality and security improvements, PISP solution, which we'll discuss later today, and also supporting the demo working group that is part of our product council. On the community side, they're following on the updates Simeon gave yesterday. And we also have the special interest groups for the 4 APIs listed here, the admin, FSP interoperability, a third party, and the settlement APIs setup. Most of them are working and meeting on a regular cadence. So if you are interested, please reach out to Michael, who's the rapporteur on the CCB, or myself, or the conveners on each of these SIGs. We have Miguel, Henrik, and Luis as the conveners on those. Wanted to give a chance during this session to call out our DA, who's been doing great work. And we'll have Godfrey and James coming on to give a brief 2-minute update there. Apart from that, various other forums where the community can get involved are the community Scrum of Scrums that happens bi-weekly, where we have work stream leads across all of Mojoloop open source giving updates. And on Mojoloop Slack, we have several channels listed here, which interested contributors, people can take advantage of. With that, I'd like to invite Godfrey, who was our chair before we had the elections, and James, who's the newly elected DA chair, to give us a brief update on the DA. Godfrey, are you ready?
Yes, thanks, Sam. Yeah.
Go ahead.
What I'll do, I'll just quickly go through, an overview of the DA, and also pick up 1 or 2 issues that we handled. Then we'll just hand over to James just to say a few words, but I'll handle much of the talk here. So just for those who are new, just as a refresher, the key responsibilities of the DA as one of the 5 committees that are actually being put aside on Mojoloop. We will look deeply into looking after the design uniformly, and to ensure that all what we're adding upon the API is well coordinated, and it also follows various technical standards and design principles. So that is in a nutshell, and it has been there from the inception of the project up until today, working alongside with the Change Control Board before the other 3 committees were in place. And on the second point, in terms of the constituency, previously it was mainly members that were actively involved in building the core from scratch up until today. But with the new Mojoloop Foundation in place, we're required to restructure it and formulate it on a formula that is transparent to anyone. And that actually included looking at a way of bringing in all the workstream leads, because the workstream leads, that's where the knowledge sits, as well as to balance it with about 5 elected members, which will be people from the community, may not be part of the core team working on the product. And through that, we also have to further on, as the DA members, nominate a chairperson to replace myself. And that process has went on, and James Bush has been elected as the new chairperson for 2021. And the duration for these members are only 1 year. Then after 1 year, there will be a new process of getting other members on board. And we're still accountable to the TGB and the community that stays the same. And in terms of functioning, we are an open community to everyone to reach out to on design matters. And we just restrict people to try as much as they can to reach out via the GitHub under the DA authority workspace, so that we can record much of what is happening in there. We used to do a lot of Slack communication and all that, but it's also allowed for open communication. But to formally send out issues to us, we prefer that the issues get recorded on the appropriate channels. And in terms of how we meet, is every week, every Wednesday, I think 1 p.m. UTC now, the new time, and also ad hoc meetings if there's more other discussions to be taken place. And obviously, when we meet, we look at the board, and we look at what needs to be, prioritized, based on its priority. Then from then we take it for board discussions. And in terms of what we're doing currently on a little bit of transformation activities, version 2, we are being asked by the TGB to really document the platform principles that were actually used to take the directions and the decisions around the design of Mojoloop. And it took us some time, more time than we expected, because of much of the diverse views that we have in the community. But fortunately, we have that documents ready. It is being handshake with the TGB, and Michael tomorrow will present it to the community. And the other process, which is still internal to the DA and initiated from the product council side, is the creation of charter, specific to how we're doing our work, to incorporate our goals, objectives, and mission. So as soon as is available, we will take the same process and bring it up to the community for input and review. Next slide, Sam. In terms of the issues we have handled, last PI, we went through a process of cleaning up a little bit of what we had on the board and trying to reorganize it as much as we could. So we created a new template that is simple for people to put the issues, summarize the issue, stipulate the time frame expected for the decisions to be made, and also indicate the entities it impacts, so that when we evaluate the issues to be tabled, we can ensure their completeness before being tackled by the DA. And second to that was really to just make sure that we take everything according to the PI, and this actually came as a request from the TGB to try as much as can to organize and know all the decisions that we're taking as we go along, so that in 4 or 5 years' time, we can have a very good record of that. So we just started by taking everything we're doing this PI with PI 12, and unfortunately, all what we have done previously is just in one back. But James and I will work towards trying to see how we can, go through all that backlog and organize it going forward. So going forward, it will be much more cleaner. As we start PI 13, it will be a new board with issues that will be kind of like moved over, those who are still open, like the design review of the RFM, and those that are completely closed. And we'll actually use this opportunity, Sam, to really, make decisions on those that are easy and put them to closure. And yeah, in a nutshell, that's the work of the DA. And as Sam has indicated, James is the new chairperson. And I'll hand over to James just to say a few introductory notes. Thank you.
I'm not seeing James on the call. Simir, do you see him?
Yeah, I think we can pass. There's another slot for Michael tomorrow, and he can appear on that slot. Yeah, thanks.
Thank you. Thank you, Godfrey. So one note I wanted to add on the IAC contribution, what we are presenting in demos today, we are working with our partners and stakeholders so that it gets fully adopted into the Mojaloop open source community, and that we have the documentation, tutorials, and there is a video which we'll see in the payment manager session later today, so that we can lift the baseline experience and make it easier for all Hub and FSP participants who are using Mojaloop. So that's the goal on the contribution. With that, we move into the focus areas for the core side, this PI. Again, I'm only representing one of the contributing teams here. We intentionally left half side of this team to recognize the community contributors, people helping with the roadmap, the DA choices, pointing out bugs, issues, and many other contributions. Otherwise, this is the core team focusing on the core related work, this PI. And this is from the community event a year ago in Johannesburg. And as Paula promised, hopefully soon we'll meet again in person. So we look at the continuous growth settlement, where we are, what we had to do to get it OSS ready, the reliable notifications design, and some maintenance updates. The last two have their own sessions. So the testing toolkit and the architecture POC. So we'll look into those in detail during those sessions. On the reliable notifications, again, I'd like to invite Miguel over to take it from here.
Thanks, Sam. So last MojaCon in July 2020, Mawali expressed their frustration on how notifications and timeouts were being currently handled by the Mojaloop platform. And this is one of the initiatives and one of the designs in an attempt to address specifically the notification portion of those issues. And in addition, we've also introduced some further improvements into how the notifications are handled by the Mojaloop platform itself. So starting off, let's just try talk about the problems that are being addressed with the notification reliable design. And the first being that the current notification handler does not currently support or does not have a retry mechanism, right? So if there are any temporal network issues or any kind of problems like that, the handler is not able to recover and retry those requests that one would expect. Temporary network availability issues is something that one can generally see in the real world, and as such, the notification handler must be able to cater for those. The second is the notification handler does not currently provide, or rather has a minimal feedback on delivery of notifications. So at the moment, there is some basic monitoring through our Grafana dashboards, where you can see an error code and the associated source and destination FSPs, but it's very basic and rudimentary. Importantly, there's no options or no ability to create reports, and there's no way to handle compensating actions as a result of that, at least out of the box. Of course, you can manually do it, or you can plug something into that and do it yourself, but we're trying to do a much more consistent and reliable way to do this. The last part, which to me is more about improving the notifications in general, is the central components for the notification handler or the adapter is not easily pluggable. And the reason for this is a lot of the core notification logic is actually tightly coupled to the notifications adapter. And that really should be more in the central component space. So we have some tracking issues. We have a story and a DA link on the bottom left. And on the right, we also have a pull request, which is a draft high-level design that's currently in progress at the moment, that the DA has reviewed, added comments, and is currently being worked on. Next slide, please. So this is just a quick overview of what the current notifications handler, or how it currently works or functions. So in the middle, you can see there's a top, or rather, let's start at the top. We have a top bar called the ML API, and this is a component that's split into two specific microservices. A transfer API component, which handles the incoming FSP IOP requests, which you can see on either side, one for the payer, one for the payee. And we have in the center the notification event handler, and that component listens to notification coming from the central services below, and it acts based on the types of events, and one can expect events to be produced for notifications based on prepare requests, fulfillments, aborts, timeouts, validation failures, maybe even internal errors, and some alerts as well. But inevitably, the notification handler is going to consume these events from this topic, and it's going to send those notifications out to each of the payee or the payer, depending on the logic that it currently has based on those events. And you can see with this picture, there's a couple of issues, right? There's no feedback loop that goes back to the central services, which is a problem. And as mentioned, there is minimal visibility in terms of what happened. There is logging that happens on that component. So through Elasticsearch, you can go and see what's happening, and you can also potentially add alerts in events that you can create based on that. And also we have the Prometheus that I mentioned before. But inevitably, it's quite, there's not very much, the visibility is not the best experience, at least from an operational and maintainability perspective. And as mentioned before, because of the tight coupling of that logic, that notification handler is not very easy to switch out. So if you wanted to introduce another handler to handle maybe a different kind of format, or maybe a different kind of MIME type, perhaps introduce an ISO 2000 a notification event handler, you would have to reproduce that logic. So the transposability of these handlers and the adaptability, the pluggability is not very easy at the moment. Next slide, please. So moving on to what's changed. Well, in essence, we've split out the notification handler into two distinct components. Sam, if you can go next, please. We've removed the logic and pushed that down to the service layer in essence. And we've now, at the top, we have a notification engine. And what I mean by this is we have a new component called a notification command handler. And this is a stateless microservice in essence. it reads events from a notification command topic. Can you press next, Sam? And it's going to filter out the events that come from that notification command topic based on the transport and the MIME type. Importantly, those events are generic and are use case agnostic. They're not merge loop specific. Those commands purely contain the information that you need from a delivery perspective, the MIME information in terms of how you're going to decode the contents and how you're going to process it, as well as reliable configurations. How many times must I retry it? Must I publish a delivery report, as well as the headers and the payload of the actual notification that needs to be sent out. And then this component, as mentioned, can also now produce a delivery report, which you can see on the right. That gets published to a notification events topic as well. And inside of that delivery report, we have things like the metadata that indicates how long the delivery request took to that particular participant. We also have the retry metadata, how many times it took to retry it if necessary, and the result status, whether it was successful, whether it failed, which includes the error information if necessary, and if there's any response information that came back from sending the notification, like headers and payload, that you would expect. The next, let's talk a bit about the bottom part. So the notification event handler, once again, it's going to consume the same events that we saw as the as is. There's no major changes per se. That is pretty much as is at the moment. If you can go next, Sam. And so now let's focus on the event handler specifically, that it is now not stateless. It's now storing information about the notifications itself. When it creates a command, it generally would note that. So basically, when a delivery report comes back into the system, we can update that particular notification with more information in terms of whether it succeeded, or maybe whether no delivery report ever received, but you have some way to track that and acknowledge what's going on through some kind of reporting mechanism that the notification event handler would provide through an API. But more importantly, this is where now the logic sits to produce those notification commands. So this notification event handler will basically have the logic to process those notification events that are being produced by the central services. It will know that I need to send a prepare notification out of fulfillment, etc., and it will know how to construct that and create the command appropriately. Of course, it will also have an API to query those notification report statuses. But I would say the biggest benefit here is we can now potentially do compensating actions. So what I mean by that is the notification event handler could potentially reschedule events if necessary. It could also create alerts, and it could also do actions on transfers. So for example, if a prepare couldn't be sent out, the notification event handler could proactively abort that transfer if necessary. Of course, at the moment now, timeouts would generally handle that, and the transfer would time out if no notifications are sent out. But in essence, we have the ability to now do that and be more proactive. And of course, all these capabilities together help us or enable us to monitor and enforce SLAs. And what I mean by that is, traditionally, we didn't have a good way to monitor the time it took for a notification to be sent out and for a participant to respond with a callback. Maybe we sent out a prepare request to that payee, and they sent back a callback to say, hey, we're fulfilling that transfer. Now we have the reporting and the data that we need to be able to determine that participant, that payee, took so long to actually respond to a notification, which I think is very important from a hub operations and enforcing SLAs, etc. So in essence, can go next slide, Sam. In essence, this design really provides the retry mechanisms that I initially talked about. We have a feedback loop via the delivery reports to be able to persist that, and we have now the reporting capability to query that, and that can be used to manage SLAs. And we have also support for compensating actions. And the last part there is about separating of concerns. The event handler, once again, has the core logic, has the APIs for reporting, and has the ability for compensating actions. And we have the command handler, which is stateless and is purely a notification engine, a retry mechanism. And once again, it is very pluggable. In future, we can easily add another adapter in, for example, ISO 2000 standards if we need. We can introduce that, and then we can then make sure that the MIME type and the transport type match that. And we can have those two adapters running in parallel and processing notifications appropriately based on those, based on the contents of the events that are created and the commands that are produced by the event handler. So what are the next steps? Well, the next steps is to go detailed design. So the high-level design that I've discussed now is being provisionally approved by the DA. So we need to go into detail and potentially, hopefully, implementation in the next PI. How can you help? Well, as mentioned on the first slide, we have a pull request open. Feel free to go review that and add your comments. That would be much appreciated. Thanks.
Thank you, Miguel. This is one of the critical items that we are addressing right now. One of the pillars or the invariants that Michael will discuss tomorrow is that a payer FSP should always get notified. So what we're doing now lays foundation for that. And also it has implications for things like eventual consistency and the usage of GET transfers, things like that. So looking forward to continuing on this. So the continuous growth settlement feature was implemented by the TIPS team. There was the OSS settlements team that built on that. Right now, what we did this PI was to take the code base available in a CGS branches, get them OSS ready and merge them into master branches so that they can be included in Mojet Loop release. We had a request from some of our implementers and community members for the CGS and interchange fees. So this was prioritized for the PI poll. I'd like to invite Valentin to walk us through the updates and the future here. I also want to credit the team that developed this. We had Michael actually who talked about this until July over various community events. We had the team Jane, Thea, Neil, Dion, Lazula, Eugene, Joe, and others who worked on it, and possibly many others. Kudos and credit to all of you. And yeah, Valentin, please take it over. Also, time check, I think we are at 18 minutes to the line. Thank you.
Thanks, Sam. Hi, everyone. So I'm going to explain briefly what the CGS and interchange fees are and how they work. So the continuous growth settlement process is basically a real-time settlement of committed transfers. How it works: as soon as a transfer is committed, the accounts are settled, and in our previous setup, what the net debit cap for a DFSP for the FSPs is actually the available liquidity in continuous growth settlement model. Can you go next, please, Sam? So what we're having are two accounts per DFSP. The position account holds what hasn't been settled yet, and the settlement account or the net debit cap limit shows the available liquidity. As I said, after a commit of a transfer, the settlement process, so after a commit, a message for a successful commit has been placed on a Kafka topic, and as soon as it is consumed, the settlement is processed. So what happens is that the position after the settlement is finished is reset every time, and the liquidity is changed after each transfer. Once again, Briefly, when a transfer is committed by the payee, the settlement API service consumes the message for successful transfer, then updates the position. After that, marks the settlement, the transfer is settled, adjusts the liquidity check, and resets the position. And this happens on both payer and payee with respective movement of the funds in or out. And other than continuous gross settlement, we have the interchange fee settlement, which is a mechanism that calculates and provides a way to settle fees between the DFSPs. Can I have the next slide, please, Sam? So the way the interchange fees are organized is the following. Right after the successful transfer is committed and the message is consumed from the settlement handler, there are scripts with rules which define how an interchange fee will be accumulated, and after the script, the continuous gross settlement continues. For the interchange fee settlement, the process is pretty much the same as the previous settlement version 1 deferred net strategy, without the need of liquidity check, because the amounts that are going to be settled are between the DFSPs, and as I said, it's organized in the same manner as the previous settlement. So this means we have settlement windows, and they are closed on some period, and they are settling the interchange fee accounts independently from the continuous gross settlement. Can I have the next one, please, Sam? Yeah, so as I said, continual gross settlement, when is the only model of settlement, it works like having just one window that is never closed, and all the transfers are settled in real-time fashion, and in a situation where we are having continual gross settlement and interchange fee both active, the continual gross settlement is settling each transfer, and the script that sets the rules and calculates the interchange fees is accumulating sums into the interchange fee accounts, and on closing of a settlement window, those sums are settled. So this is pretty much the overview of the interchange fees. Can I have the next one, Sam, please? The changes that we have done to be able to get the donated code into the master branches of the central ledger are pretty much those here. So we've added the settlement model to have a mandatory currency and unique constraint of the settlement model based on currency and ledger account type ID. So we've done that because in theory there is no restriction to have only one settlement model working, like continuous gross settlement or deferred net, but to be able to have those working together, we had to have restrictions per ledger account type and currency, so they don't raise any conflicts. Also, we've added a functionality to create participants accounts per settlement model. When the settlement model is created, we've refactored the code to meet the OSS standards. Here are the peers listed. For the central settlement changes, we've split the handlers into separate services, and we've done so far a little bit of refactoring on operational and deploy configs. And still we have some items to cover. What we want to do is to separate the rules engine from the CGS handler, since now you can use interchange fees or any kind of rules basically only if you're using the CGS model. We need to refactor the central settlements domain and models to align with OSS design standards. We need to introduce the event SDK into the central settlements. And we will also move the test scenarios in the TTK, since the donated code came with Postman tests. I will not do a full demo now, but we will have a video recorded later.
You can go ahead and share.
Yeah. So basically in this collection, what we are doing, we are preparing, we're closing an existing window if there is something open. We're preparing the balances before the transfer. Then we're getting the balances before the transfer, as I said. Then we're starting a transfer. So you can see, for example, here the position is like that for this, for test FSP1, and for test FSP3, yeah, it's the same. Maybe our onboarding should change a bit so that those are zeros. So we have this as a position and this as settlement. Then we make a transfer, and after the transfer, the position stays the same, and the settlement, or actually the liquidity, has moved, and which is the case. Which is the case again for the other FSP. Also, we have accumulated some interchange fees. But yeah, the full demo with every step and all those data explained will be available after that. Thank you, everyone.
Thank you, Valentin. So we didn't go too much into the demo here because, as you know, we've covered this multiple times, and Michael even walked us through like an Excel sheet with the steps on how the positions and settlements and the ledger account, based on the ledger account type changes. But there'll be a video recording of this in the agenda page. Thanks for that, Valentin. I think we also would be nice, we need to add to the roadmap an MTP program course on settlements itself. We're at 6 minutes, so we'll quickly go into the Helm release part. I'll hand over to Miguel without much delay. So this is the process we typically follow. We iterate over the release candidate several times to make sure there are no bugs, and test the upgrade and default deployment scenarios to make sure it works, and then release to the community. Yeah, feel free to comment and give us your feedback on that. Miguel?
Hey everyone. Okay, so we're running out of time, so I'm going to try to rush through this a little bit. So last PI, we were working on a version 11 release for Helm. Just to reiterate, Helm is what we use to package Mojo Loop, and it's the way that we're able to package it as a single deployment. So version 11 ended up being released around about the mid of this PI. Due to some issues that we had to resolve as part of it. But inevitably, version 11 is now available, and it includes some updates. The Mojo Loop simulator is now enabled by default, so which is great. So when you deploy it, you now have those simulators ready to go. The second is the testing toolkit now has been included as part of the Helm release, and it's also enabled by default as well. So once you deploy that, you're able to use the testing toolkit and to run tests and interface with the simulators that are deployed. And the testing toolkit is able to onboard the hub, it's able to onboard the simulators, and it's able to run golden path tests. The testing toolkit also has the ability to run jobs as part of the Helm scripts. So for example, you can run a job to run any of the three mentioned above for onboarding or golden path or onboarding simulators. You can run them on demand, you can run them scheduled. So if you want to run nightly tests to make sure everything's running regularly, you can do that. Or you can run it as a post hook for Helm deployment. So when you deploy Mojo Loop, you can then have them run and verify that that installation is running as we expect it to run. And the last part is the Helm charts now support Kubernetes version 1.16 and above. So Kubernetes deprecated some of the APIs. As a result, there had to be some changes in the Helm charts to be able to support the more recent versions of Kubernetes. So that's currently what's available. And for future, we're now busy, we have been working on a version 12 release candidate. And this now includes some additional improvements. So for example, the jobs that were mentioned before on 2 and 3 as part of Helm version 11, we're now going to be able to package those in Helm tests for the toolkit. And we're also hopefully going to tentatively include the ability to run Postman Helm tests as well as part of that. That's tentative. We might scratch that. We'll see how that things go. If we can fit everything into the toolkit Helm tests, we'll go with that. And I guess the most important thing is it will include the continuous growth settlements and interchange fee functionality that Val took you through. So as part of that, we have a new Helm chart called Transfers Handler that's part of Central Settlements that handles that functionality. And the last thing is we're busy working on any fixes that we find. So for example, I don't know if you guys are aware, but Docker Hub has introduced some throttling in terms of how often you can pull Docker images from their repositories, depending on whether you're logged in or whether you're anonymous. So we've made some optimizations to the Helm code where we currently have a policy where we always pull the images. We've changed it now to only if needed, we'll pull the images down to help reduce that throttling issue. And the last thing is about deploying Mojo Loop or multiple Mojo Loops in the same namespaces. There was a bit of an issue that stopped us from doing that. There's a fix now in this version that will then allow you to deploy into multiple namespaces. And that's more to make sure that we're adhering to the best practices from a Helm perspective. Yeah, thank you.
Thank you, Miguel. We'll quickly cover some maintenance updates. So we had the bulk functionality working prior to this PI, but we had been approached by some of our community members to get bulk working for them. So we were able to support them, tweak some the simulator and SDK a little bit to make enhancements to better have bulk working for them. Apart from that, we have did some more QA and testing on the version 1.1 of the FSP interoperability API implementation, and support for sub-ID in the SDK scheme adapter. So support for that was missing in the account lookup service on the get parties calls. So now that's available. And there are some bug fixes as usual, and we were able to support the community contributors with PR reviews and documentation changes as needed. So I'll skip talking through this diagram, but the bottom line is that we now have a testing toolkit collections that will automatically, using this command here. So when a Mojo Loop deployment is done by default, there's a post-install hook, which will trigger the testing toolkit to run a setup collection that will set it up, and then run a test collection that will test and publish results and gives a Slack notification. So that is all automated now. This is a representative list of bug fixes we have in this PI, fixed around 15 to 20 bugs, and primarily supporting the community members on bulk upgrade issues, supporting the sub-ID functionality, some infrastructure issues, more stricter validation on FSP interoperability headers, and Swagger not appearing as a documentation link on some of our core services. That was fixed as well. With that, I think we are almost there. A few things we need to continue the reliable notifications as we discussed to finalize and implement that. And a decision is also needed on the performance scalability proof of concept because things like forensic logging and some refactoring of code are dependent on that. And of course, the business operations framework, standardizing the admin API, which is actually in progress. We'd like to continue build on that and work with the settlements SIG as well to make sure both of these are standardized. We'll take any questions on the discourse and chat, but I would like to wrap it up here if there are no urgent questions.
Thanks, Sam. I can see lots of chatter in the chat. Please jump on there and respond to some of the questions. And for everybody else, please feel free to add your questions and discussions on Discourse.